Hi everyone, let's try to solve this problem, lowest common ancestor of a binary tree. So we are going to be given a binary tree and two nodes, and we have to find the lowest common ancestor of those two nodes. So let me just take this example here, and suppose our nodes are 5, 1, okay? In this case, what is the lowest common ancestor? We see that 5 is here and 3 is here, and the lowest common ancestor of this is going to be 3. Similarly, let's take 6, 4. In this case, the lowest common ancestor should be 5, right? And let's just take 7, 4. This should be 2. And let's take 7, 8. In the case of 7, 8, it has to be 3. So let's try to revise an algorithm for the same. Now let's take the simple case of 5, 1. In this case, if while we're traversing the tree, if we encounter a node which is equal to one of the nodes given, P or Q, then let's just return the node 5 here, and here let's return 1. Now if the return value is not null, right? The right side return value is not null, the left side is not null. In this case, let's return the node itself, which is 3, and the least common ancestor will be 3. Similarly, let's try to do it for 6, 4 case. Let me remove this. Okay, now let's try to do it for 6, 4 case. In this case, while we're traversing the tree, here we'll find 6, we're going to return 6 here. In this case, we're going to return 4. And here it's basically, since we're not finding anything, we're going to return null. And in any case, if the left is null, if any one of the nodes is null and one is not null, then we have to return the not null value. So here let's return 4 itself. And now we see both, this is not null and this is not null. So we're going to return 5. Here on the other hand, we're going to return null. So here let's return 5 again. So the answer is going to be 5. So now these both test cases worked. Now let's try to do the same for 7, 4. In this case, what's going to happen? Then second. Okay, 7, 4. Here we're going to traverse till here, we're going to find 7. Here we're going to traverse till here, we're going to find 4. Here, since both are not null, we're going to return 2. This is going to return null. This is going to return 2. This also works. Now let's try it for the last test case. The last case, which is 7, 8. Okay, in this case, what are we doing? We're going to traverse till here, we're going to return 7. Here we're going to return 8. This is null, this is 7, so we're going to return 7. This is null, this is 8, so we're going to return 8. This is null, this is 7, we're going to return 7. At the end, both are not null, so we're going to return 3. So this also worked. So now let's try to write a pseudo algorithm for the same, pseudo code for the same. So we're going to be given find ancestor, suppose a method is called, and we have the root node, comma, we have P, comma, Q, which are the which are the two nodes for which you have to find the common ancestor. Okay, if root is equal to null, like in this case, we have to return null. Okay, if root is equal to P, or if root is equal to Q, let's return the node itself, root itself. So basically, when we encounter a node which is one of these P or Q, we have to return root itself. Now let's find the left node of this, which is basically we're going to recursively call the left node for root P, Q, and simultaneously we're going to call the right node dot right P, Q. Now this is the main logic. If left is not equal to null and right is not equal to null, in this case, what did we do? We return the node itself. So here it's not equal to null, here it's not equal to null, we have to return root itself. Return root. Okay, and now if left is not equal to null, that means right is equal to null. Again, let's return left. Similarly, if right is not equal to null, we're going to return right. If both are equal to null, then let's return null. Okay, so now let's write this code in the editor and see if it works. Okay, so let me just give it like this. Now if root is equal to null, we are returning null. Then if root is equal to p, or if root is equal to q, then let's return root. Otherwise, let's call the left node is equal to lowest common ancestor root dot left comma p comma q. Similarly, let's call the right node lowest common ancestor root dot right comma p comma q. And now if left is not equal to null and right is not equal to null, then we return the root. Now if left is not equal to null, let's return if left is not equal to null, then we have to return left. If right is not equal to null, so return right, and if both are equal to null, let's return null. Okay, now let's try to run it and see if it works. Okay, let's submit it and see if it works. Yep, looks like it succeeded. The time complexity for the same is going to be O of n, since we're going to iterate through all the values only once, and the space complexity will also be O of n due to the internal stack which we use. Thanks everyone for tuning in. Bye bye.